Today's topic is on abstract data type, or ADT. Let's take a look at an iPod. When you have an iPod, you play music. And on the iPod, you will find the button for play, forward, rewind, pause, next, and so on and so forth. The instruction manual tells what it should do without letting you know how it is implemented inside. Say, for example, play. You could play the current list, current song, or there are many other type of play. That depends on the functionality of the device. For this case, on the iPod, when you do play, you will go ahead and play the music. And this is really different from the implementation that is underneath. Because, for example, nowadays, the devices are all electronic. So when you do play, it's all done electronically. But in the old days, when we had Walkman, for example, they were cassette tapes. So when you do play, there were mechanical ways to play cassette tapes. But despite the fact that they are different, the play is still function as to play the music. As you can see, there is a separation of how you specify a function from how it can be implemented underneath. And this is why we also use what we call it a data abstraction. Data abstraction helps us to simplify the software development by decomposing the complex text of developing a software system by separating the specification from the implementation. So today, I'd like to introduce you to another dichotomy, and that dichotomy would be specification and implementation. So there are two sides of it. One is to specify something, and the other side is how to implement that specification. So there are two sides of this. When you do this, and what you could do is that you could continue to reuse the specification, although the underneath implementation could be different. As I said before, the play button is still the same, whether you have a mechanical implementation or electronic implementation. On the new iPod, for example, there could be newer processor, there could be a new programming language, but your specification of a play still would be the same. Henceforth, your specification can be reused over and over again, while the implementation underneath may change from time to time. In C, let's look at what are the basic data types that we have before we talked about what an abstract data type is. So here we see a simple chart that lists out all the arithmetic data type in C. So you have the basic of a character, CHAR, or integer. The integer could be a short, it could be a signed short, it could be a long integer, and the way that each one is implemented would be different. For example, some of them are within the range of 256. Some of them are within the range of minus 32,767 to the positive 32,767. And you can see from here that for a long integer, it is from minus 214,748,3647 to the positive 214, 74A3647 range. So again, the specification, short integer versus long integer, and how they are implemented underneath, the way that they use the memory underneath, they're different things. Now let's look at what is an abstract data type, or ADT. First, let's talk about what a data encapsulation or information hiding is. Well, it is the concealing of the implementation of a data object from the outside world. And data abstraction is the separation between the specification of a data object and its implementation. Earlier, what we say is that a data type is a collection of objects and a set of operations that act on those objects. So when we say integer, for example, that's an object. What we can do with the integer is that we could do addition, subtraction, multiplication, and division. And there may be some operators. But we may not be able to do first, last, intersection with this particular object because that particular object does not support those operations. So you can see that the specification of the object and the implementation are again separate and are different. So here, abstract data type, ADT, is a data type that is organized in such a way that the specification of the object and the specification of the operation on the object is separated from the representation of the object and the implementation of the operation. We just see this abstract data type from another angle. So ADT is a set of operations. And abstract data types are really mathematical abstractions. Nowhere in the ADT's definition is there any mention of how the set of operations is being implemented. So now we can see that based on the very simple building block from the data types, we may be able to describe a higher level of abstract data types. Objects such as list, set, graphs, along with their operations, can be viewed as abstract data types. Very much so, just like integers, real, and Boolean are data types. There is no rule telling us which operation must be supported for each data type, abstract data type. This is your design decision. So for a set abstract data type, if you add some more function, that could be another set abstract data type. Error handling and type breaking are also generally up to the program designer. So it is very clear that you need to specify your abstract data type very clearly to the user before they can be used and they can be also implemented. So in the next few videos, we're going to see how abstract data types be manifested in list, in stack, and in queue. And if they're done correctly, programs that use them will not need to know how each implementation was used. For example, if we have an abstract data type called set, we may have such operations as union, intersection, size, and complement of that particular set. Here again, we have the implementation, the specification. But how this is being implemented, it really it depends on the programmer. You might use you might use an array, you might use a list, you might use some other data types to implement this abstract data type called set. And as we said earlier, how you define your data structure, all right, will affect how you do the implementation. Here we can see that alternatively, for the set abstract data type, we might only want the two operations, union and find, which now would define a different abstract data set on the set.